There is my screen visible?
Yes, ma'am, it's visible.
Yes. Good evening, everyone. Myself, I'm Uma Devi. Basically, I'm a math tutor for the past 20 years. My hearty welcome for every one of you for joining the session today. So today's topic is geometry. So how can we make our classroom little more lively and fun for the children? So the topic we have chosen is geometry made fun. Now, before we start to that session, let's do a small activity. It's a small your hands exercises. It's a brain gym exercise. So you can hold your left hand as right hand like a circle. So you can tap on the table. So the top you will tap like this. When you are moving, you will move your hands exercise like this. Okay. So are you ready? Can you all join me doing? You can do it on your table or on any flat surface. Okay. So you'll tap your left hand straight, right hand make a circle. So you'll tap like this. Then move down. You'll change your position. So left hand moves down to a circle, right hand a straight line like that. So repeatedly we'll do it. Are you all ready? Have you understood what the
Yes, ma'am.
exercise is? Have you understood what the
Yes,
exercise is?
ma'am.
Yes, okay. Shall we try?
Yes,
Just
ma'am.
we'll do for on 10 countings, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can do as fast as we can. Then as we are doing the alternate different movement, so both our left and right brain will be getting activated. So we can make a small startup activity for our class also. Hope you liked it. So we'll move on to the session. We'll start that. Now, once again, I'm going to give you some questions. Feel free to have an interact session. Just feel free to give your answers for my questions. Give me a situation without involving numbers. Can you give any situation in your life? But the condition is not involving numbers. Yes? Can anyone try? Is that an answer? Is it possible? Is it possible or not? Yes, can I have any answers? Let me continue. So I hope it's not possible. So each and every of our life situations, we have numbers. We include numbers. So we can conclude saying that math is everywhere, isn't it? Have you all agree with me? Are you all agreeing with me? Now, can I have my second question? Give me any object without a shape involved. You think of any object in and around you. Just have a look around you where you are sitting. You pick up any object. Can you say a object? A single object without a shape involved. Can give your answer in the chat also. We cannot have a particular object or even a single object without a shape involved. So we can say that geometry is also everywhere. Geometry is in and around us. We live in the world of geometry. What is mathematics? So our human computer says that without mathematics, there's nothing you can do. Everything around you is mathematics, and everything around you is numbers. So with that short belief given by our Ma'am Sakuntala Devi, we'll move on to the next. So what is geometry? We all know that it's a branch of mathematics. It comes from the word taken from the Greek words geo and metron. We all know that. Now, Euclid. I hope you all know the mathematician, great mathematician. Geometry is knowledge of the externally existent. He is known as the father of geometry. So this is a small introduction about geometry. Now we'll move on to what is the significance? What are all the importance of geometry? It develops the geometry knowledge, helps every human being, every person to have a better understanding about spatial reasoning. That is, we can visualize and understand the relationship between objects and the space. Then, how do we apply geometry in our real life? Any branch or in our life, any of the work we do, any of the profession we do, we become. For examples, art, architecture, any field of engineering, robotics, sculpture, space, nature, sports, machinery, vehicles, and much more. Everywhere we involve geometry only. It improves the logical reasoning, logical thinking, critical thinking are developed. Then it makes us understand our nature, and definitely we'll come to that, the appreciation part of the beauty of our nature. And it develops finally the creativity. When we admire the nature, when we start appreciate, definitely we'll start creating much more from that, isn't it? So everything, when we take from the olden days, it's all coming from the observation of nature, understanding the nature, then we are getting admiring the nature, then based on that knowledge, we start creating. So that only we have developed this much and we have reaching this AI, isn't it? Now, let's think, how can I make my geometry class interesting for my children? So each and every of the concept of geometry, we can relate to the real life and make the children doing some fun activities. So when children do something, they definitely relate to their life and they never forget it. So first, I'll start with the basic geometrical elements. So how can I do a very good lively activity class in mind. Okay. And these are all the activities I did it in my class with my children. And it was really a successful one. So that only I'm here to share all those things. So here we are going to start the activity with the children itself. There is no materials needed for this activity. Only our children are going to do this activity, and we are going to involve all the children in the class, whether we have 20, 30 or whatever, how many ever they are. We can involve all the children in our class. Now make the children come forward as per the instruction. So the teacher will understand the activity better, and one after the other the instructions will be given by the teacher followed by the children. So first I'm going to call a student. Come on, a student, come forward. Now we are going to stand in a particular place. So you are here in this particular place. So how can I locate you? So you are in this particular place, for example, near the table, near the board, or in the center of the classroom. So we are locating. So that is a point. So a point helps us to locate objects. So that is the first basic building of geometry. Next, I'll call three more children. Come and join that points. So there are so many points coming and joining. So it's a collection of points. It makes a line or a ray. It can be extended both the side. Now two children we can call. We can ask them to join from one side. One student is firm. So let's ask the children to join only one side. So one is the fixed point. So the other side I'm extending. So a starting point, but the other side it's extended. So we are framing a ray. Now I can give my instructions. Call two or three more children joining on both the side. Now both the side it is extended. So both the directions are going endlessly. So now we are getting a line. Now you can point out any two children on the line. For example, Raj and Rani. So from Raj and Rani, so they are only starting point and ending point. So this is a particular space in between a line. It has the specific distance. So it is a line segment. So when I'm extending the line, we cannot measure the length, measure the distance. So the line does not have a definite length, but the line segment has the definite length. So we can introduce like that. Then we'll call four more children. Starting from one point, they'll ask them to make another line. So one particular point. So there are children standing like this. Now we can introduce the distance between these two lines. We call it as an angle. So it's not the straight measurement. It's going to be the curve measurement. So we need two rays or two line segments or two lines from one particular point. So they have one common point and both the side extended. So the in-between curved measurement is an angle. So like that, we can make all the basic geometrical elements with the children. Now finally, after this, so these are the building blocks: points, ray, line segment, and angle. So after this, then we can ask them, now where are we all standing? What do we need for us to make stands right? So it's children automatically say that, Mom, it's a floor. We need a smooth surface, all those things. So it's next, it's called a plane. So where are these elements are? On the plane. So what is a plane? It's a flat surface extending in all the directions. So by simultaneously we can give there the definitions also. Okay. So where are we? Where are these elements? They all are on the floor. It's nothing but a plane. Yes. Next we'll go for the lines. Now with that, we can complete that one session of the classes. Then next day we can continue what types of lines are they. So here we can do the paper folding activity. So if we have the paper, we can take a paper and ask the children what it is. It's a plain surface. It's a plain surface. Now you fold vertically and give a firm, just make a press it well and open it. So what do you get? It's a straight line. Okay, now make it the folding horizontally. Now you open. Now you have two lines. So the two lines are meeting at one point. It is at two lines, a pair of lines meeting at one point. It's an intersecting lines. Now ask them to fold the paper diagonally. Now we have three lines. All the impressions will give them the lines and fold them the opposite side diagonally. Now we get four lines. So by the impression, we'll be able to get the many lines. More than two lines are meeting at a point. So we call them as concurrent lines. And the meeting point is called point of concurrency. So all these can be done with the paper folding activity. Now we'll talk about the angles. Once again, ask them to take a fresh paper, fold it, and the impression line, let them draw the line, and we can give them the protractor to measure it. When we form a L shape, it's a straight. Both the lines, horizontal line, the vertical line, are in the L shape. So the angle in between those, or the measurement is exactly 90 degree, it is known as right angle. So all these angles can be done with the paper folding activity. Then we move on. Ask the children to observe their own classrooms, their surroundings, on the walls, the meeting point of the ceiling and the wall, the corners, are their edges of their tables, and take the book, find the edges of the books. So they all are meeting at 90 degree. So first we'll start with the 90-degree angle. It's a right angle. Then we'll ask them to show the lesser than 90 degree and more than 90 degree. Okay, then we can ask them to give many pictures in the projectors. We can show them, or otherwise paper clips can be given them to show the junctions at the road, the railway track, the runway on the aeroplane, isn't it? So all those things we'll ask them to check how they are. Then the electric cables, we will look outside the classroom. The electric cables, how they are going. So they are going in a straight line like this. They are not meeting one another. The four lines or five lines or electric lines are moving like this. So the distance between them is same. They are straight to each other. They are moving. They are not touching one another. They are not meeting one another. So those lines are called parallel lines. So when the lines are meeting, they are intersecting. When they are not meeting, they are parallel lines. So we can give all different types of lines using the activities. Now, types of angles, we'll have a separate activity. First, we'll use all the body parts. Children really love to do this. You need not tell them you have to fold your fingers, fold your arms, nothing. You just ask the children, get from their places, stand comfortably. Now come and show me a right angle, because we have taught them a straight line makes the 90 degree. Definitely children will show it. Either they can use their fingers, they can show like this 90 degree, or they use both the arms fully stretching their full arms. Yes, so they can show the 90 degree. Now come on, make little lesser than 90 degree. Obviously, they will reduce their size. So it's an acute angle. So come on, show through all your body parts. Definitely they can show. They will bend their arms and they will show that lesser than 90 degree. So now you all are looking cute. So these angles are acute. So we can tell them the words also. So they never forget. You give small patting, appreciation, and make some fun in the class. Definitely children will remember that throughout their lifetime. Okay. Then identify the angles in their surroundings. As already we have discussed, the walls, not only the walls. Now you can ask them, where are you looking at the different angles other than 90 degree? So they can look at the ceiling. So they definitely come with it, the blades of the fans, isn't it? Yes. And the angles shown on the windows, everywhere they can identify the different type of angles. Next you give them, now you create angles using some sticks. Whatever is available or whatever you are able to get it, you give the toothpicks or the ice cream sticks or some matchsticks. Come on, create 90 degree right angle, acute angle. Now the more than 90 degree, how do we call? Obtuse angle. So slowly you introduce the words, the pronunciation, the spelling, everything on the board and make the children do their angles on their tables. Next, find the angles in each alphabet. So you can write all the alphabets using the capital alphabets. You give some examples, one or two. Children will complete the remaining. So here I have shown only capital A. So here first mark all the angles. Wherever you see two lines meeting, you mark the angles. Next you try to tell what type of angle they are. The same way, write the digits using only straight lines, you will get angles. If you are writing with curved line, we are not able to get the angles. So write the numbers, digits 0 to 9 using straight lines. Now come on, identify how many angles each have. So it's very quite interesting. The number is related to the number of angles in it. So 0, it doesn't have an angle. Number 1, there is an angle. Number 2, we are able to locate 2 angles. Number 3, 3 angles. So children really love to do this. You just show them 1 or 2. So definitely they will extend it further. Yes. Next I'll move on to this little higher classes. It's the lines are not visible. It's again a paper folding activity for doing the parallel lines. We have completed parallel lines. So next we'll move on to the transversal. So when we fold one time, ask the children to take the paper. First, fold it one time. Open it. Fold it again. Open it. Now you are getting two parallel lines. Now fold it the way you wish and open. So you will be able to get parallel lines and a transversal. That's what the picture I have given. Now after this, ask them to mark all the angles. So the top portion we will be able to locate 4 angles. The bottom we are able to locate 4 angles. Now give them the protractor and measure the angles. They'll be able to measure and find out all the equal angles. So we can make them measure from their answers itself, then we can give the property. Previously, if you are telling that no interest, it can be a rote method of learning. Children, there are parallel lines, a transversal cuts it. You will have alternate interior angles equal, your corresponding angles equal. Definitely, children will become boring. So let them explore it. Let them find the angles. Wow, these two angles are equal. Wow, the other two angles are equal. How am I getting only the two measurements repeatedly for all the angles? So let them enjoy finding them. Then finally we introduce the terms. If we tell the terms previously, Children definitely think that math is very tough and difficult. Math is of more of terms. I'm not able to remember the terms. If they do it, oh, I did that. This two angles equal, I got it. So that only I'm giving them the angles name. Alternatively, I'm getting equal angles. So they are alternate angle. And they are inside the line. So they are interior also. So let them bring the words, their own words. Then we will little correction alone we can do. Then our job becomes easy. Yes. Now we'll move on to the closed figures. Till now we are just opening. Only lines are joining, angles only we have discussed. Now we'll move on to the closed figures. So first we'll give them the thread. Ask them to make a closed figure, an open figure. So if you are giving a small length of a thread, they'll join together the edges. They'll be able to make a closed figure. If they're not joining, they'll be able to get a open figure. Easily we can name them. Now give them the name. See, a circle, we made it with the full curved line. So we call it is a non-polygon. Then what is a polygon? Okay, instead of thread, now we will give them the sticks. The ice cream sticks or math sticks, whichever are available with us, we can give them. Now also you start them with the one stick. Give only one stick. Will you be able to make a figure? No, ma'am. Then come and take two sticks. Come and make a closed figure. Now also it is only opening, ma'am. I'm able to make a V or they'll tell something, isn't it? Only I'm able to make like an angle. It's not closing. So next, how many minimum number of sticks needed to make a closed figure? Ma'am, only one more stick we need. So definitely they'll be coming with the answers. So 3 sticks are minimum needed to make a closed figure. So then we will move on slowly. Come and make a figure. So how do we call it? How can we name it? Now come and take 4 sticks, 5 sticks. So we can slowly increase the number of sticks and give them the names also. So as per the number, the names also different. So slowly we can introduce the polygons name as well as the definitions also. Now, what are two-dimensional shapes? Now we will give the definition for two-dimensional shapes. Now here you are representing all these things, isn't it? They all have two measurements. Where can you show them? Will you be able to carry and show it to your friends? Will you be able to carry and give it to your friends? No, definitely not. So children will automatically say that, Mom, will be able to show or represent the 2D shapes only on a flat surface. So they are two-dimensional shapes. And it does not have a thickness also. We cannot carry it. So now you ask them, which are the shapes you are looking in and around you? The 2D shapes. Wherever you are looking at, now list down the places where you are looking, list down the objects where you are looking, and what are the shapes you are looking at. So definitely they'll be able to do it. Now we will give the dots. I hope you all, math teachers all know this. It's all isometric dots. We can give them the dot paper. Now come on, you try to give two-dimensional shapes or the three-dimensional shapes, whichever you are able to, using the dots and the straight lines. Now, what are 3D shapes? Three-dimensional. So what are the three-dimensional? Now you try to build. Already you have prepared, you have created a triangle, a rectangle. Now come and make it as bigger more than, taller more than. So what do you need? You will automatically, you will increase the height. So when you increase the height, it becomes like a box. You'll be able to carry it. So now we have 3 dimensions. So they are called three-dimensional objects. We have length, breadth, and the height. Now we can move on to the next step of creating the three-dimensional shapes. Nets. So what are nets? So the flat 2D representation is called nets. When you fold all, when you cover up, you will become a closed box, a 3D shape. Now ask them to bring, or you bring them and show the all the covers, whatever we are purchasing, toothpaste box or any soap boxes, or the things are packed and coming in boxes only, cardboard boxes only. So all those boxes can be brought and they can be shown how this was created in the manufacturing places, the industry, how they are preparing it. So when you cut and open, it's all coming like a flat chart paper. So that is only called net. So these are all I only have created. So when you pull out the thread, you will be bringing into the shape of the 2D flat face into the 3D. Yes, I hope you are able to see this. So when we pull these two threads, they will be automatically joining together and we'll be able to make a closed box. Yes. Next, what are the another idea to create 3D shapes? We can rotate the 2D. You take a 2D shape, you rotate, you will be able to get a 2D shapes. You can rotate the coin and show them. If you are rotating a circle, you will be able to get a sphere shape. Or otherwise, we'll build. First, we'll make the frame. Then you will increase the height. You will make a 3D shape. When you take a rectangle, a frame alone, for example, the boundary, we say that the perimeter. You take only the framework. Now you keep on arranging. When we are increasing to a certain height, it becomes a cuboid. Show them the bangle, the hoop. So it's only the boundary of the circle. And that is increased to a certain height, we get a open cylinder. Do that with the coin. Do that with the coin, you'll be able to get a closed cylinder, isn't it? So we can create a 3D shape using different methods. So I'll recall once again, we can use nets, or we can rotate the 2D objects, or we can build them. Next, we'll move to the beautiful topic of symmetry. So first, you'll take them to the nature walk. Quickly, 10 to 15 minutes, you take them out of the classroom. It really makes the classroom lively. Always why monotonously inside the four walls? We'll take for a walk in our campus itself. You make them group in the class itself. Make a group of 4 or 5 children. Tell them you shouldn't pluck more leaves. And here we can include the values also for our life. See, plants are our basic need. They are all our natural resources. We shouldn't hurt them. We shouldn't harm them. So don't pluck as many as leaves and flowers you can. No. A team, one person, only one leaf or a flower. Okay. Then only we can have different leaves as well as different flowers also. So first you observe, you admire the nature. While returning back to the class, everyone can have only one leaf or one flower. So these instructions all can be given in the classroom and we'll take them to the outside the walk. Now when they come back to the class, everyone will have a single leaf or a flower. Now ask them to sit with the team and observe that. Okay, come on, what do you see from that leaves and the flowers? Now come on, can you fold and check whether they are equally one side half is matching with the other side half? Are they exactly looking one another the same, both the sides? From there itself you can bring. So definitely there are more leaves and symmetrical. And we may have leaves without the equal halves also. So now we can introduce the words. So when we have equal halves, they are symmetry. When they do not have the equal halves, we say that it is asymmetrical. Yes. Now, wherever you are looking at, you can bring them. So it can be a small take-home homework. Now tomorrow you can bring different pictures or different objects you see in your house where you are looking at one half is equal to the other half. So they can do by folding. Or now the next step is now you create pictures using the symmetrical. How do you create it? So it's very simple. You take a paper, you want to make a symmetrical shape, isn't it? So first, what can you do? You make the paper folding into equal halves. So draw only one half and cut the fine. Open it, you will be getting beautiful symmetrical pictures in your hand, isn't it? So the one the teacher can do the demo, isn't it? So here I have many things. I'll show you. So it's just only one chart paper. I have folded into two equal pieces. Just I have only curved line drawn and the fine cutting. Now I'll open. It will be like a beautiful butterfly flying, isn't it? So one or two examples we'll show. Children will be bringing more than what we expect, isn't it? Then we'll go for the next symmetrical, the mirror. So the classroom itself, we can bring the mirror and we can make them stand in front of the mirror and do their activities. Yes. Now you can bring all the needed elements. Yes. So when you lift your left hand, it seems to be lift the right hand. So it's only the mirror image. So what are the things you want to bring the mathematically? You can bring slowly. Then rotational, you make them rotate. Even after one rotate, you are standing as it is. So how many times you are rotating to bring back your original? Now you take any object. Now you make it rotate. Okay. So you can tell them all these are rotation. What you did is self-rotation. Now you are rotating the objects when it comes to the original position. So we can give all the input slowly one by one. Yes. Next, we'll go for the axis or the line of symmetry. Now it's a 2D drawing. In the 2D drawing, we draw the center line to make equal halves. So it is called line of symmetry. When it comes to the 3D shape, how can I cut it? I cannot cut only the top or a little bit. I have to cut from the top to bottom to make equal halves. Isn't it? So it's not one line cutting, it's one full plane is cutting. So we say that it is an axis of symmetry, isn't it? So you will slowly improve the knowledge according to the grade level. Yes. Now based on that, now you slowly tell them admiring the nature, admiring the symmetrical from the nature, we people started creating. Now we can show the beautiful monuments. The monuments all are coming under the symmetrical only. For example, Taj Mahal, Charminar, everything are exactly each and every part of the building is symmetrical. So here, these are all some paper cutting made by children only. Next is, it's going to be the next little more upgradation of the paper folding. It's origami. The origami is the wonderful and excellent activity which is very important for creating the huge things in our life. Yes. And to the wonder are all these space craft what we are sending to taking the photographs. We need all the elements. They all are done with the help of origami only. So all that elements, we put it very much concised shape in the satellite and sending. After reaching the particular place on the particular orbit, they'll open up. So that's all we can show in the video to the children. And here also, these are all done only with the help of the origami to decorate the classes. So we can ask the children, come on, this is your own classroom. Are you wish to decorate your room, your house? You do all these things. So this with the small color papers, We can make our children engage as well as indirectly learning also. Then give them the task. Now you draw pictures, isn't it? You draw beautiful pictures. How do you draw? You need many lines. You need straight line, curved line, isn't it? Now I'm going to give you the task. Draw the diagram only using the straight lines. So here these pictures are used only with the straight lines. Yes, so straight lines also make really amazing wonders. So first give them the dot paper. So these are all the dots connected with the ruler and pencil. Would you all please focusly observe it? So each and every dot from the first dot to the last dot a straight line. Then next two dots are connected with the straight line. Everywhere it is straight line only. But see the illusion it created. We feel they are all beautiful petals drawing with the curved lines. Isn't it? So that's the wonder of math, I believe. Yes? But audience, from your side, do you agree with me? Any questions or any doubts? Shall I proceed it?
Yes, ma'am. Beautiful pictures.
Yes, thank you, ma'am. Thank you. So these are all children only drew, ma'am. We have the books with only the dots. So the look here, it's only the 3 lines. And we have the dots equal distance. And children are asked to connect one first dot to the last dot. Now take scale pencil, you start connecting the dots with the straight lines only. So these are all, the framework will be given, connecting the dots using the straight lines. So once they did it, they can do the beautiful shapes done with the straight lines. Next, what else can be done with straight lines? So it's nothing but it's a Warli art. So completely the drawing comes from our geometry only. So now we can tell them use only triangles and circles. Create diagrams. Then we can reveal it. These are all not we created. All our ancestors have done. These are all the beautiful Warli pictures found in the caves. Isn't it? Next one, mandala art. So mandala art is also nothing but it's a gift of geometry only. We use all straight lines, curved line, shadings. We can create the mandala art. Yes, these are all my children's work only, ma'am, from various grades. Right from grade 5, 6, 7, 8, all various children's work only. Not even a single thing is done by mine. It's all only the input, a sample only shown. Children come with the beautiful, their own creatively created ideas and the pictures. So nice. This is a decoration done by the children in the classroom. Now we'll bring them to the real life. Where do we use the 2D shapes in our real life? So all the signboards. Now whenever you go out, so observe very carefully wherever you see the shapes. So we are using shapes, the straight lines, the curved lines, completely the geometry only helps us our real world a meaningful one. Isn't it? We create all our signboards, smileys, everything with the help of the lines and the shapes. Then we'll go for a little, the bigger the project. Now come on, create your own house, your own building, the future engineers, future architects, we can see in our classroom itself. So make the model of the uh, playground or the park or the houses, yes, or the dams, everything. So these are also children only did. Now, shall we have a small song? Are you all ready to have a song?
Ma'am, we cannot hear to the song. You need to share the sound. There is an option share sound.
Geometry gives us all our shapes, you see. Well, can't you see? Circles, squares, prisms, spheres. Shapes that look like rabbits' ears. Shapes of grapes and apes and apes. Shapes of apes hiding out behind the drapes. Time to make a great escape. When shapes are forming into apes. Geometry, geometry, geometry gives us all our shapes, you see. Well, can't you see? Circles, squares, prisms, spheres. Shapes that look like rabbits' ears. Shapes of straights and shapes of plates. Shapes of plates. Naming, using all those shapes. Yes, all those shapes. Circles, squares, polygons. And all the shapes you've ever drawn.
Circles, squares, polygons, all the shapes you've ever drawn. Ovals, cubes, prisms, spheres, shapes that look like rabbit's ears. Hexagon and octagon and pentagon, all be gone. Pyramids here, squares over there, all the shapes that I can bear.
Geometry, geometry, geometry gives us all our shapes, you see. Well, can't you see? Circle, square, prism, spheres. Shapes that look like rabbit's ears. Angles, curves, diamond swirls. Shapes I often do observe. Make me dizzy, make me sigh. Geometry's one busy guide. Circles, squares, prisms, spheres, shapes that look like rabbit's ears. Hexagon gives us all our shapes. Polygons and octagons, septagons, pentagons, geometry. Now geometry gives us all our shapes. You see, well, can't you see? Geometry, geometry, fill a void. Oval gives us triangle shapes. Don't forget the rectangle, spiral, angle, cone, star, wedge. Shapes that have no edge. Pyramid gives us parallelogram. Geometry is who I am. Geometry, geometry, who I am. Gives us all our shapes, you see.
Is that good to hear? Have you enjoyed it? Is that good to hear?
Yes, ma'am. Interesting.
Interesting. There are so many different age appropriate songs are available, ma'am. So we can download and we can take it to the classrooms. Now, next interesting activity is the tangrams. So from the 2D shapes itself, we have so many beautiful puzzles. So it's one of the Chinese puzzles, tangram. So it's nothing but a 7 pieces puzzle. We have a square, a parallelogram, then 5 triangles. So we can just show only one sample. Children be able to make thousands of images. We can make humans, animals, birds, a different whatever thing we need, we are able to make. It's completely on our creativity only. So here also the tangram alone picture taken. The remaining all children's work only. It's all about only children's creativity only. So they can make the different shapes. So by this, their logical reasoning, their spatial relationship, and everything will be really developed. And there is another puzzle called pentominos. So pentominos is a 12 pieces puzzle. So all these are available in the market. We can purchase it. That according to that school, the management, we can discuss them and we can purchase n number. A minimum of 20 pieces to 25 pieces enough to take it to one particular classroom, I think. So these are also again, we can make so many animals, birds, or any objects. It's a creativity. So here we can easily identify with the alphabets. There are 12 pieces are in the representation of 12 alphabets. So we can easily identify the pieces also. So here I have given you only the examples. Now the next one is the rangometry. Rangometry is the foam sheet. It's a beautiful soft foam sheets 2D shapes available in one full bag. The full bag have nearly 100 pieces of all these different sizes of triangles, trapeziums, hexagon, pentagon, all those shapes in different bright colors, beautiful bright colors. So we can create as many as objects, images possible. So here also it was done by our children only.
Excuse me,
Next.
ma'am.
Yes, ma'am.
In the earlier picture, you showed pentominos.
Pentominos. Yes, ma'am. Yes, ma'am.
Ma'am, penta means 5. How come they are 12 pieces?
Ma'am, actually, the kit is called pentominos. There will be 12 pieces available. Very good question, ma'am. Thank you for remembering me. Pento means 5. So here each shape is created by 5 squares. Okay, thank you for giving me the right time, the right input, ma'am. I have forgotten that. Now, for example, you look at the first one, the P shape. You look at there are 5 squares. So next
Thank you,
X.
Thank you,
Yes,
ma'am.
ma'am. So each shape is made of 5 squares. So that
Got-
only the name is given as pentominos.
Got the clarity, ma'am.
Yes, thank you, ma'am. Thank you. No, I have to thank you because I have forgotten to include that point. Thank you so much, ma'am. Next, it's a rangometry. So now from these only, we have developed to the mobile games or the video games. I hope you all have seen such games in our mobiles, isn't it? A puzzle will be given. Only the outline will be there. Bottom there are shapes. We have to take it and create that entire figure, isn't it? So these are all the recreational mathematics. So math is not only for calculations. So people, we may have always the mindset as math is tough. Math is only for calculations, only numbers. It's boring, isn't it? So we can make people come out of that mindset that math is only giving space for creating all fun games. So we have the separate branch called recreational mathematics, which gives all these beautiful games. So these are all used by the small shapes to matching the puzzles all created with that only. So now from this, we can make our children understand the concepts better by giving the simple and exact definitions. So I hope I have come to the conclusion. So using these activities, we can make the children understand the concepts. Slowly we can give the input of the definitions, not at the beginning. And whenever we are giving the examples, we have to give them the non-examples also. So children should have the clarity, which is I'm talking about, which are the things to be included, which are not. Next, make sure that let the children do their assignments by themselves. Plan for the age-appropriate assessment. So all the activities I have given right from the lower grade when we start geometry till the grade 8 level. All that lines and angles, parallel lines and the transversal, all different type of three-dimensional shapes. So I have included everything as a pack of geometry. So we have to choose the grade appropriate activities and the assessments. Now, these are all some photographs being taken. I can conclude saying that geometry made our world. Hope you agree with me. Is there any agree or disagree? Do you all agree with me?
Ma'am, totally
Yes,
agree,
ma'am.
totally
Ah.
agreed and thoroughly enjoyed your session. Although
Thank
I
you
am
so much.
from English background, but
Ah,
the examples, live examples you gave, I
yes,
appreciate
ma'am.
your.
Thank you so much, ma'am.
You thoroughly involved all of us in your
Thank you so
subject.
much, ma'am. So here, whatever the pictures I have given, no, that all the one sample I did, everything is my children only made. If you want, even I have everything here with me on my table. If you wish, I can show it there, everything. So all the net, all these pictures and this cutouts. If we say some program in the classrooms, they'll completely decorate the classrooms. Only the papers and the scissors to be given to them, they'll be beautifully decorating the classes. So we will have a art corner in each class in our school, ma'am. Students corner will be there. They can do all the concept oriented of all the subjects, and there will be the art gallery. So children will do a small things even will be clipped over there. A small token of love. A star is more than enough for our children. A smiley picture drawn and you'll display it in the classroom. So they really love to do more and more every day. Any queries or comments? Anything you would like to share with me? You feel free to have a final the comments or feedbacks from your side. I'm expecting.
Ma'am,
Yes, ma'am.
very patiently you explained all the concepts.
Thank you so much, ma'am.
You really deserve a round of applause.
Thank you so much, ma'am. Thank you so much. Thank you, ma'am. Actually, it's a very vast branch of mathematics. We cannot complete within a day. I would like to bring still more deeper the concepts in coming future sessions. I really try to do all those things, but definitely I'll come with the deeper understanding and knowledge for the grade wise, a specific concept wise.
Ma'am, we'll look forward to that.
Definitely, ma'am. Definitely, ma'am. And here the final pick of my thank you. These are all the clay did by my student only, ma'am. She presented to the teachers, all the math teachers. So the final, the slide, thank you slide, the pictures are given now. It's all made by the clay, one of my students, ma'am, that I really want to share with you all. She says that, Mom, these are all the motivation you gave us. So we really love to do some extra work during our weekends.
Wow, ma'am, you really deserve them.
Thank you, ma'am. Thank you so much. And
Yeah.
my wholehearted gratitude, thank for every one of you for patient listening to me. I'm really thanking Sir only, Ravi Sir only, for giving me such a wonderful opportunities to share all my knowledge and all that thoughts of mine to my dear mates also. Thank you so much, sir.
Yeah, we are also very happy to have you as a resource person in SNTTC,
Thank you,
ma'am, no
ma'am.
doubt about
Thank
it.
you, thank you,
And I
thank you, sir.
request you to give a few inputs about our Train the Training session, as our
Hmm.
new batch is starting from 2nd
Yes,
of
sir,
August,
definitely.
so
Yes,
that
yes,
interested
definitely, sir.
participants can yeah, know
Yes,
about it.
definitely I'll do it, sir. Yes. Thank you, sir. Thank you so much.
Yeah, so dear participants, hope the session went very well. And I wish you all have had a good time listening to ma'am. So now, as an important announcement, I would like to inform you all that our 14th batch of Train the Training course is going to start from 2nd of August. So interested participants can ping me on my WhatsApp number for more details about the course. So those who wish to become successful resource persons like Uma ma'am and the other like resource persons whom we have at SNTTC, you can definitely register for the course and become a wonderful trainer. That's how it